Hello friends, in this presentation I am going to take you through the challenges that the Indian telecom operators are facing in their ability to monetize 5G network. Now we all know that Indian telecom operators have invested huge amount of money in deploying 5G networks, and in order to sustain this deployment the monetization of 5G network is absolutely essential. So that's why it is important for us to understand the bottlenecks so that we can work holistically to remove these bottlenecks so that monetization of 5G network is possible. Now, before we get into the challenges, we have to understand the capabilities. 5G is a different technology and it has different capabilities compared to 4G networks. Now, 5G offers exponentially high data speed compared to 4G because it has the capability to aggregate large quantum of spectrum which 4G was not capable of. Then 5G technology makes the network more intelligent compared to 4G. 4G offers a basic telecom network, whereas 5G, the network is intelligent enough to understand the traffic flow and optimize the traffic flow so that the traffic can be routed within the network depends upon its usage. Let's say if there are traffic within the network which is going to remain within the edge of the network and it doesn't require to travel to the core, then 5G can understand those traffic patterns and route those traffic patterns within the edge of the network to prevent the network within the core getting congested, which the capability 4G could not offer. Then 5G has the capability to slice its network into different pipes, which are basically which flows within the internet, which is the bigger pipe, which typically normally the traffic is carried. Now this internet is a pipe which terminates within the 5G network and doesn't flow into the internet. Let me explain. Let's say if I want to access a service offered by a telecom OTT player who doesn't want its traffic to flow into the internet, he can have an agreement with a 5G operator and terminate his server directly into the 5G network, and that will flow into my mobile phone without having to go through the internet. Only place where the traffic is getting shared is within the 5G network, and because the slices are going to be going to be different from a virtual path within the internet, there is a distinction between the traffic which is flowing into the internet and which is flowing within the internet. So this capability 5G has compared to 4G. 4G doesn't have the capability to distinguish the traffic in the manner which I've just described, and that has made the 5G network quite different from 4G. Now 5G has the capability to offer these sliced traffic which I'm going to call VAS, which are going to remain compliant with the net neutrality rules, and I'm going to explain to you how this is going to remain compliant with the net neutrality rules. Whereas since 4G doesn't have the network slicing capability, so they will breach the net neutrality rules if they are going to offer services similar to what 5G is capable of. Now the other important feature of 5G is that it kind of replicates wireline over wireless. So what basically it means is that as in case of wireline, the network speeds, your experience of usage is not kind of limited or kind of directly linked to the usage of your neighbor. Let's say if you have a house and your neighbor is sharing the same pipe or the same cable into which your cable is also traveling. So then your usage, because it is a nailed up connection, it has got no linkage with the neighbor's usage, therefore your experience remains constant. Similarly, in case of 5G, this capability is built in with a capability called beam steering or splitting of an RF beam into multiple pieces or multiple beams which are going to remain segmented out in the wireless spectrum spatially. So therefore your experience remains constant even though somebody else in a neighbor using the same spectrum in the same BTS located in the same geography where you are trying to use the network. Whereas in case of 4G, because the beam is common, therefore, as the number of users increases within the sector, your experience will diminish because everybody will like to access the same RF beam simultaneously. Now let's talk about monetization. Now monetization is possible under two different verticals. One is rapid data speeds, another is offering VAS, which is network slicing. So I'm going to talk about these two different capabilities separately. Now, in case of rapid data speeds, there are two different form factors where this rapid data speed can be experienced. One is the mobile phone, another is the fixed wireless device, which we call FWA. Now, in case of mobile phone, the problem is that the mobile phone hasn't been able to deliver an application which requires these kinds of speeds, except for, let's say, video conferencing or maybe a couple of other applications. So most of the applications are kind of okay working within the 4G network. So you really don't see a distinction between 4G and 5G services as long as you are using these applications. And that's the challenge, because there are no killer applications available yet within the mobile phone which will significantly enhance your experience because of the speed. Whereas in case of FWA, this is not the case, because in FWA what's happening is that the terminal, which is the CP, is located at a convenient place where you get a line of sight with the BTS, and that is going to enhance the capability of this pipe significantly, because this pipe is running on high frequency spectrum which has got a lot of capacity. This spectrum, I'm going to take you through this slide later, but this is the spectrum talking about, because this spectrum doesn't penetrate indoors. So since this spectrum doesn't penetrate indoors, and it is a very thicker pipe, so you will be able to terminate this signal here, and then within the house you can either run Wi-Fi or you can basically terminate your computer coming from this antenna directly into the computer. So that's how you will be able to leverage rapid data speeds using an FWA, whereas in case of mobile phone, this kind of capability does not exist. Now coming to the bottlenecks. The main bottleneck here is that these FWAs or FWPs are, the price of these FWPs are quite expensive compared to a normal router where you terminate your optical fiber cable or an ADSL. Because these are expensive, these will only scale when the volumes are very high. It's a kind of a chicken and egg situation. And today, since the volumes are not that great, therefore the biggest challenge that the operators will face to make sure that the prices go down significantly before they scale up to a large number of customers. Though the potential exists, because we have only 30 to 35 million fixed wireless subscribers or broadband subscribers who are running on wireline networks. So there's a huge potential to expand FWA devices in India, and that's the lowest hanging fruit where the monetization is possible. However, there is a challenge also. It's not so simple to say that FWA will be able to provide that kind of monetization opportunity, because unless these bottlenecks are removed, which are in the face of the network, like you need to have the capability to drive traffic end to end. When you start from your computer here, it goes to the BTS, and then it goes to an hub here, and then it goes to the server, where it has to be end to end. There should not be any bottleneck, neither from the point where the computer is located to the device, because this is going to be Wi-Fi. There should not be a bottleneck here, and then there will be a backhaul here. There should not be a bottleneck. But in case of 5G networks today, bottlenecks are in both the places. You have a bottleneck here in the backhaul network, because there are many BTSs which are not terminated on optical fiber cable. They are terminated on microwave. So there is a bottleneck here. And here, let's say if you consider this as an FWA, the Wi-Fi network, which is going to get connected in the computer, because FWA is going to terminate here, and then later there has to be a link here for Wi-Fi. The Wi-Fi network speeds are limited, and they don't have the capability to leverage this great speed, in gigabits, which is going to be offered to this FWA. So that's the bottleneck. Now the other challenges are going to be that as you create more capacity, as I told you, that network slicing is possible. So if you have an internet pipe, and if you are not using this intranet, then you have, this is the volume of the pipe. So all your traffic is flowing in the internet. But as soon as you start offering this network slicing service, you have to borrow capacity from your internet pipe. Now that is going to diminish the capacity of the internet. Means if you have a pipe running within a pipe, naturally the volume of this pipe is going to get decreased. Now this is going to be a challenge, because unless this pipe, this whole internet pipe, the bigger circle is big enough, if you are going to have another slice within this pipe, then the capacity of this pipe, which is the brown part, is going to get decreased, and that is going to eat into the internet. So any intranet traffic which you are going to support within your 5G network is going to eat into your internet traffic capability, and that's going to be a problem, because you don't want the internet part of your capacity going down, because this is going to further percolate down here, the net neutrality rules. Because if the internet capacity reduces, then this fast lane that you're offering using the intranet, that will face a regulatory challenge, because as soon as you go to the regulator and say that I want to offer the fast lane, which is not allowed today, then what will happen is, then they will say, okay, I will allow you to offer this fast lanes, but I want you to maintain the internet traffic constant or keep expanding the capacity of the internet usage, because where everybody is going, right? It's all traffic is running through internet, except those traffic which is going to run through this fast lane. So this challenge is not going to be there in the high frequency part of the 5G network, because the high frequency part, let's consider this as the 26 gigahertz band, and 26 gigahertz band, you know that some of the operators have taken 1 gigahertz of spectrum. Similarly, this is 3.5 gigahertz band. You know, the operators have taken spectrum between 100 to 130 megahertz. A huge amount of spectrum is there. Whereas the lowest part of the network, which is 700 megahertz, only 10 megahertz of spectrum is available, and one of the operators doesn't have a spectrum. Means two operators doesn't have. Actually, you know, if I call them, RGO has 2 into 10 megahertz here. Bharti doesn't have any spectrum here, and neither Vodafone Idea has. So because the lower frequency band doesn't have any spectrum, so what will happen is that as soon as you start offering your VAS services, or you do network slicing in order to offer services directly into the mobile phone, here each and every application is trying to use a separate slice of the network. Then what happens is that if your mobile phone is sitting within the house, then you really don't have access to these frequencies, the high frequencies. You only have access to this lowest frequency band. And if you eat into this capacity, which is a very thin capacity, then your internet capacity, this internet pie, is going to shrink, and you will have a problem in running the best effort traffic. And that's where the net neutrality rules will have a challenge, because the regulator will like you to keep the capacity of the internet constant or expanding as you run your VAS services. So unless you expand this spectrum further, the low frequency band spectrum further, it will be very difficult to offer you these network slicing service within the mobile phone without challenging the net neutrality rules. So that's in short, which I wanted to basically explain to you, that these challenges have to be overcome. And we have already identified the challenges, that we have to have more backhaul spectrum or optical fiber capability. We need to expand the Wi-Fi capacity, means we need 6 gigahertz spectrum to be delicensed, and we need Wi-Fi 7, which can aggregate between the various Wi-Fi band, like 6 gigahertz capacity plus 5 gigahertz, and then the 2.4 gigahertz. All capacity can be aggregated using Wi-Fi 7, so we should leverage Wi-Fi 7. And then you need to expand the capacity of the low frequency band further in order to fully leverage the network slicing capability of 5G. Now what I did was, I actually have been writing many articles on these topics. So what I'm going to do in the comment section, or in the sections below this video, I'm going to list out these articles which you can go and further expand on this concept which I have explained in this article. Thank you for your patient listening. Thanks a lot.